In this example, we're going to be using voltage division to find voltage V1 and voltage V2. Now this voltage divider works when things are in series. We can see that we have these two resistors in series, but it's not clear what voltage is across them. So what I recommend doing is redrawing your circuit so that it looks kind of like the examples that you were given. So for example, we'd have some voltage source, we'd have a resistor, we'd have a resistor. These resistors would be in series. So this would be kind of like what an example would look like. And you can have more than two resistors in series. So if I kind of move this down, I have a 54 ohm resistor here. I have an 18 ohm resistor here. Across this is that voltage 1 that we're looking to find. And then the question is, what is the voltage? Well, the voltage is the voltage from this node up here to this node down here. So we can take this path, or we can go straight here. If we look up here at this problem, this node is that node, and this node is this node. So the voltage across it is this V2. And it's okay that it's a variable, because we can go find it later. So now we have this 16 ohm and this 80 volt. We haven't used them yet. So let's draw a simplified circuit that looks like kind of like our examples for voltage divider. So again, you can have more than two resistors, but for this problem, it only has two. So we have our 16 ohm here at top. This is 80 volts. And again, if you don't remember, the smaller terminal in the battery is negative, the bigger terminal is positive when it's drawn this way. So the question now becomes, what is this? So you might say, oh, it's the 36 ohm, but that's not true. It's actually all of these resistors combined together. So if you kind of remember back to the last homework, if you combine the 54 and the 18 and then combine those with the 36, then you'll simplify this end of the circuit down to become this resistor. So that's what we have to do. So we can redraw this circuit. So we'll have some R equivalent being our 54 plus our 18, and that is going to be 72. And then if I kind of redraw the circuit, so we'll come back to this. So now I've taken this thing. We have our 16 ohm. We have our 36. And now we have that 72 ohm resistor. And then we can see that these two are in parallel. So I can combine them. So 1 over R equivalent, if you want to do prime, that's fine, will be 1 over 36 plus 1 over 72. Our common denominator is 72. So I will get a 2 here and a 1 here. And I will get 3 over 72. And then we need to flip this back over. So R equivalent, I guess prime in this case, is 72 over 3. And if you plug that in, that'll simplify down to 24. So this is what goes right here. So this is our 24 ohm resistor after we simplify the circuit down. This is pretty easy to do voltage divider with. So let's bring this back down. So we want to know the voltage right here. So this is this top node. We'll call this A. This is A. This is this bottom node. We'll call it B. Here's B. So these all match. By the way, this is A and B as well. So this is V2. So these nodes are the same nodes for all three of these diagrams. So once I find V2, I find this side. So let's apply voltage divider. So that equation is Vx is equal to V total Rx over R total. So the voltage that I'm looking for is the V2. The total voltage across all of our resistance is the 80 volts. The resistor of interest is this 24 ohm. Again, do not plug in the 36 because all of these resistors are part of that. And we simplified that. So this would be 24. And then our total would be the 24 ohm plus the 16 ohm. They are in series in this diagram. And so if you do that math, you will find that it is 48. So we have 48 volts for V2. And we can verify that with our answer key up here. All right. So let's go back over to this diagram. So now we know that this V2 is 48 volts. Again, this is node A to B, so the voltage from A to B is 48. We just found the voltage from A to B over here. We just apply voltage divider again to find V1. So in this case, same equation, Vx equals V total Rx over R total. In this case, we're going to find V1. Our total voltage across both of our resistors is this 48 volts. The resistor of interest is 18 ohms, and then the total is 18 plus 54, which we've established as 72 earlier. So you just do your algebra here, and you will find that this is 12 volts. And if you wanted to prove all of this, you don't have to use voltage divider. You could go back and use your Ohm's law and your KCLs and your KVLs, your fundamental laws, and you could verify that all of this matches up.